The universe is 13.8 billion years old. It contains 2 trillion galaxies, each hosting billions of stars and trillions of planets. By all mathematical laws of probability, the night sky should be screaming with alien radio signals. Space should be crowded with interstellar empires, megastructures, and cosmic traffic. But it isn't. When we look out into the dark, we find nothing but a deafening, terrifying silence. This mystery is known as the Fermi Paradox, and scientists believe the answer to why we're alone lies in a concept called the Great Filter. The Great Filter is the terrifying theory that at some point along the timeline from a single-celled organism to a spacefaring empire, there is a barrier. A hurdle so incredibly high, so consistently deadly, that almost no civilization ever clears it. It is a cosmic meat grinder that destroys life before it can leave its home world. For decades we've guessed what this filter could be. Nuclear war? Climate collapse? Rogue artificial intelligence? But what if the Great Filter isn't a mistake or a malfunction? What if the filter is an absolute scientific milestone? An inevitable experiment that every advanced civilization is guaranteed to perform once they discover the laws of physics. Today, we are going to explore a chilling hypothesis. What if the Great Filter is a machine? A machine built with the best intentions, designed to unlock the secrets of the universe, but destined to swallow its creators whole? What if the civilizations that survive the cosmos are not the ones that build the biggest machines, but the ones smart enough to build them off-world?
To understand why this happens, we have to look at our own path.
Curiosity is the engine of technological progress. You cannot build a rocket, or a computer, or medical tech without understanding the subatomic building blocks of reality. And there is only one way to study those blocks. You have to smash them together. Enter the particle collider. Right now, humanity's crowning achievement in physics is the Large Hadron Collider at CERN. It's a 27-kilometer ring buried beneath France and Switzerland. It accelerates protons to 99.99999% the speed of light and smashes them together, recreating the conditions of the universe just fractions of a second after the Big Bang. But the LHC is reaching its limits. To answer the deepest mysteries, like what dark matter is or how gravity behaves at a quantum level, we need more power. Physics demands bigger machines. Right now, scientists are planning the Future Circular Collider, a 91-kilometer monster ring. This isn't just a human trend, it's a cosmic law. Any alien civilization that develops radio astronomy, microchips, and space travel must discover quantum mechanics. And to progress further, they will build increasingly massive particle accelerators. It is a mandatory step on the tech tree of cosmic evolution. But as these rings get larger, and the energy levels scale up from tera-electron volts to peta-electron volts, we begin to flirt with a dangerous threshold. We begin to concentrate so much energy into a space smaller than a subatomic particle that we risk breaking the fabric of space-time itself. Before the Large Hadron Collider turned on in 2008, a wave of panic hit the media. A handful of critics warned that the machine could accidentally create a micro-black hole that would sink to the center of the Earth and swallow the planet. Mainstream science dismissed this, and rightly so. At the energies the LHC operates at, any microscopic black hole created would instantly evaporate via Hawking radiation, a process where black holes lose mass and vanish because they are too small to sustain themselves. But what happens when an alien civilization builds a collider 1,000 times more powerful than CERN? If a civilization builds a hypercollider on their home planet, the energy densities achieved could cross a critical tipping point. They could create a micro-black hole that is just stable enough not to evaporate instantly. Imagine a black hole smaller than an atom but with the mass of a mountain, created inside a subterranean lab. It would immediately fall straight through the laboratory floor, pulled by gravity toward the center of the planet. Because it's so incredibly dense, solid rock offers no resistance. It would pass through the Earth's crust and mantle like a ghost walking through a wall. At first, nothing seems wrong. The scientists in the control room might see a momentary power surge, a strange sensor reading, and then silence. The machine shuts down. They think the experiment failed, But deep beneath their feet, at the literal core of their world, the micro-black hole has stopped oscillating. It settles at the gravitational center of the planet, and it begins to eat. It swallows iron, nickel, and magma, atom by atom. At first, the growth is painfully slow, but a black hole's appetite scales exponentially with its mass. Within months or years, the planet's core becomes hollowed out, tremors begin, volcanic chains erupt globally, the surface starts to collapse inward. By the time the civilization realizes what they did, it's too late. Their home planet collapses into a pitch-black sphere no larger than a coin, leaving behind nothing but an empty, silent orbit. The Great Filter strikes again. If this hypothesis is correct, it means the galaxy is a graveyard of brilliant civilizations that got a little too curious on their homeworlds. But this brings us to the most exciting and perhaps the most hopeful part of our theory. If the Great Filter is a planetary particle collider disaster, then who are the civilizations that survive? They are the ones who understand a fundamental rule of survival. Never conduct an existential experiment in your own backyard. Think about the civilizations that look at the math of hyperenergy collisions and say, the risk is non-zero. If we fail here, everything dies. These civilizations consciously pause their fundamental physics research on their home planets. Instead, they focus their engineering on space colonization first. They build bases on barren moons or free-floating megastructures in the vacuum of space. And that is where they build their hypercolliders. Consider the advantages of an off-world particle collider. Natural vacuum. Earth-based colliders spend millions of dollars keeping air pumped out of their tubes. Space is already a perfect vacuum. Infinite scale. You can build a ring millions of miles wide around a moon, an asteroid belt, or even a star. Total isolation. If a space-based collider creates a stable micro-black hole, it doesn't swallow a biosphere, it simply floats harmlessly in the void, or swallows a useless, uninhabited asteroid. The filter is avoided. The civilization lives to see another day. This brings the entire theory home to us. Where does humanity sit on this cosmic timeline? Are we about to stumble into the trap? Or are we smart enough to build our off-world safety net? Right now, we are at a crossroads. We are planning bigger accelerators on Earth, but at the same time, we are talking about returning to the Moon. In fact, some physicists have already proposed building a particle accelerator around the circumference of the Moon, the Lunar Collider. The cosmic fork in the road. Option A. Chasing pure physics on the home planet before becoming a multi-planetary species. High risk of hitting the filter. Option B. Prioritizing space expansion so that high-risk, high-reward energy experiments happen safely off-world. The path of the survivors. If we see a flash of light from a distant star system that suddenly disappears, maybe we aren't witnessing a supernova. Maybe we're witnessing a civilization that turned on its final earthly machine. The Fermi Paradox tells us that someone out there is making a fatal mistake. If we want to make sure humanity's voice is heard across the stars for billions of years to come, our curiosity must be matched by our caution. We must ensure that when we finally unlock the ultimate secrets of creation, we do it safely out in the dark. But what do you think? Is the idea of an accidental planetary black hole a genuine cosmic filter? Or are we overestimating the dangers of pushing the boundaries of physics? Let me know your thoughts in the comments below. If you want to keep exploring the wildest theories of the universe, hit that subscribe button, turn on notifications, and smash that like button. Thanks for watching, and see you in the next deep dive into the cosmos.